Good morning all of you. In my previous video, I had discussed with you 6 important properties of determinants. Now let's see how we are going to apply those properties in the question. So we'll be solving the questions without expanding this determinant and by using those properties. Let's see, this is your first question. Find the determinant. Prove that determinant of this is equal to 0. So you know, if I have this addition with the element, so I can write it as a sum of two determinants. So simply I can write it as A, B, C, X, Y, Z plus again X, Y, Z, A, B, C, and then I am taking A, B, C term. Now you see, I have discussed a property with you that if two rows or two columns are identical, if two rows or two columns are identical, then without calculation I can say the value of this will be 0 plus the value of this will be 0, which gives me 0. Hence left hand side equal to right hand side. See the next question. This has, again, I have elements as sum of these two, and I want to prove determinant of this is equal to twice of this. So let's take left hand side first and separate them. So separating them will give us BCA QRP YZX plus, I can write it as CAP RPQ ZXY. Now you see, I want to get twice of A, P and X, but my A, P, X and X is lying in row 3, whereas here it is in row 1. So I can interchange this R1 with R3. So after interchanging, and I told you when you are interchanging any row, any two row or two column, then you will be writing minus. So it can be written as A, P, X CRZ BQY. What I have done? I have interchanged row 1 with R3. Okay. So same here, I can interchange. Here I need APX on my first row. So here I will be interchanging R2 with R1. So here I can write R2 interchanged with R1. So I can write it as A. Now, since I am interchanging, so sign will be minus. APX CRZ BQY. Now you see, APX has come above, but here it is BQY. So we need to interchange again my row 2 and row 3. So here I am interchanging my row 2 and row 3. So again I will be getting a negative sign. So this negative and that negative will become positive, and it will be APX BQY and CRZ. Similarly, here APX is already here, BQY I need above. So again I will be interchanging them by taking negative sign. So again it will become plus, and it will be APX I am interchanging now. So it will be BQY and CRZ. Now you see, these two are same determinant, which can be written as twice of APX BQY and CRZ, which is equal to RHS. Look at this question now. This cannot be written as sum of two. Two rows or two columns are not identical. So what we can do? Remember that property in which I have said you can multiply with a constant term to any row or column, but you have to see that you will be multiplying with that particular constant with all the elements of that row or column. So look here, if I do this operation in column 2, say column 2, in column 2 I am multiplying column 2 with 9, and then I am adding it to say C1. I am applying this operation in C2. So it will become like this. 2, 3, 5 will come as it is. I am multiplying my column 2 with 9. 9 into 7 is 63 and then plus C1. So it will give me 65. 8 into 9 is 72. 72 plus 3 is 75. 9 into 9 is 81. 81 plus 5 is 86. And third column again as it is. Now, I told you that if two columns or two rows are identical, then we can simply write the determinant of this as 0. Now you see the next question. Here it is given that without actually expanding it, you find out the determinant. So here I can do writing 1, 1, 1. This is BC, CA, AB. I can do it like this: AB plus AC, BC plus AB, AC plus BC. Now, there is nothing identical in between these. If I separate them as a sum of two determinants, then also I will not get anything identical. Let's see. If I add this column 2 with column 3, then what I get? So I am doing operation in column 3 and I am adding column 2 and column 3. So it is 1, 1, 1, BC, CA, AB, and I am doing the operation in column 3. So it is AB plus AC and I am adding C2 to it. So this is BC. Again, this is BC plus AB plus AC. Again, AC plus BC plus AB. So children, you look at this column 3, AB plus AC plus BC, AB plus AC plus BC, AB plus AC plus BC. That means in column 3, from column 3, I can take out AB plus AC plus BC common. Then I will be getting here 1, 1, 1, BC, CA, AB, and here I will left with 1, 1, 1. So again, two columns are identical. So here this will become 0, this will become 0, 0 into this will again be a 0.